Hi everyone! Today we're going to be going over the 2018 Calculus AB FRQ number 1. So the first thing we're going to do is read what the question's asking. So people enter a line for an escalator at a rate modeled by the function r of t, where r of t is measured in people per second and t is measured in seconds. As people get on the escalator, they exit the line at a constant rate of 0.7 people per second. There are 20 people in line at time 0. The first question is asking how many people enter the line for the escalator during the time interval 0 to 300. Since we're given a rate, we know that integrating a rate will give us the accumulation from that time interval A to B. So if we want to find out how many people came in the line from time 0 to 300, just coming into the line, we will integrate from 0 to 300 r of t d of t. I'm going to be using a TI Inspire, so here I can define my function r of t and use the colon with the equal sign, 44 times t divided by 100 cubed times 1 minus t divided by 300 to the 7th. This way it's easier so I don't have to keep retyping it. Now we're going to go into Menu, Calculus, click the integral, and our time interval is again 0 to 300, and we're integrating our rate in order to find the accumulation or the total amount of people that came in. And we see that this is 270. So that means 270 people entered between that time. Part B is asking, during the time interval 0 to 300, there are always people in line for the escalator. How many people are in line at time 300? So a common mistake we might notice here is that people will forget that there are two rates, one r of t entering and one 0.7 exiting. Because r of t is entering, we can consider that positive, and we can say that 0.7 is negative because people are exiting. Here we want to find the amount of people exactly at the time 300. So the first thing we should do is think about integrating our rates in order to find the accumulation of the net amount of people in line between that time interval of 0 to 300. If we integrate from 0 to 300 r of t minus 0.7 dt, we will get the net accumulation of people in line from 0 to 300. But let's think about what our integral really means. We know that this integral is saying that f of 300 minus f of 0 is equal to some number. But we only want f of 300, assuming that f of x is a function that represents the amount of people at any time x. And so in order to cancel out this f of 0, we're going to add another f of 0. And here we are given the information that f of 0 is 20. So in order to find f of 300, we will add 20 to the outside of our integral. So we're going to do Menu, Calculus, Integral 0 to 300 of our rate entering minus our rate exiting in terms of t, and then adding f of 0, which means that we have 80 people in line at time 300. Question C is asking, for time being greater than 300, what is the first time t that there are no people in line for the escalator? You need to pay attention carefully because after time 300, r of t is 0, so we can completely ignore that rate and only consider 0.7 people per second. We know that at time 300, we start at 80 people in line. So that's going to be our initial. 80 people in line minus the total amount who have exited between a time period of 300 to an unknown time t should equal to 0. And because we're good at integrating, we should know that total people exiting at a time 300 to unknown should be integral from 300 to unknown x of 0.7 dt. And the reason I'm not putting a negative is because it's right here. So in our calculator, we're going to go to algebra, solve, 80 minus the integral from 300 to x of 0.7 dt equals to 0. And we're going to solve for the variable x, so we add a comma and x. And we're given that x is equal to 414.285. And that means that 414.285 makes this equation 0, and that means at this time, after 300, there are 0 people in line. Part D is saying that for 0 to 300, at what time t is the number of people in line a minimum? To the nearest whole number, find the number of people in line at this time and justify your answer. So in order to find an absolute minimum, we're going to need a function that represents the amount of people at any time in line. So first, we're going to name that function f of x. We can use our previously defined function 20 plus the integral from 0 to an unknown time of r of t minus 0.7 dt. This is because 0 to an unknown time, or 0 to x, is going to give us the net amount of people in line from 0 to that time. We're going to add 20 because of fundamental theorem of calculus in order to find exactly f of x, because this is f of x minus f of 0, and adding that 20 is going to cancel this out and give us f of x. So in our calculator, let's write f of x, the colon equal sign, 20 plus calculus integral 0 to x of r of t minus 0.7 dt. And it says done. Okay. So in order to find a minimum, we're going to derive this, which is going to give us r of x minus 0.7. That's going to be our f prime of x because of fundamental theorem of calculus. And in order to find critical values, we have to set this equal to 0. So in our calculator, click solve. R of t, in this case, minus 0.7 equals to 0, and we're solving for t. So this gives us two possible x's or times, which is 33.013 and x being 166.574. Since this is an absolute, we also have to consider the x's being 0 or x's being 300. And in order to find which number is going to be our minimum, we're going to plug these back into our f of x equation. So f of x equals f of 0 equals to what? F of 33.013 equals to what? F of 166.574 and f of 300. So we're going to plug this into our calculator. F of 0 is 20. F of 166.574 is 158.07. F of 33.013 is 3.803, and f of 300 is 80. As you can see, this has our least numerical value, f of 33.013, is a 3.803, or about 4 people. So our absolute minimum, or the time at which there's the least people in line between 0 to 300, is time 33.013, and we have 4 people in line. If you guys still need more help with accumulation and rates, I would recommend checking out the 2000s AB FRQ question 4 and also the 2009 AB FRQ question 3. These are challenging and difficult problems that work with accumulation of rates and the representation of integrating a rate of change.